I think we're going to go ahead and get started. Um, we're going to go over tonight to a little apologetics night, talk about biology, uh, a little of the science behind biology, evolution, kind of where the science is pointing, naturalistic, materialistic worldview, or the Christian faith is more justified than what people are saying. Before we get started, Aaron, come
Cool. All right. Thanks uh, for that. So yeah, let's just bow our heads in prayer. Um, Heavenly Father, just be with us tonight as we just take a look at the creation that you've made and the reason and logic that you have endowed the world with by your mighty power. Lord, just fill us with your hearts and open our ears and minds to think about your creative work and the truth and reality of what you've done in creation and beyond creation by your strength and power. So be with us tonight, and we just lift it up in the name of Jesus. Amen.
All right. So tonight we're going to talk about biology. We did one like a month or maybe 2 months ago. We did started the series off with the astronomy, how the evidence of the heavens declares that there is a creator, how a lot of astronomical evidence points to beginning in the universe, and that implies there was a someone who got the universe started, right? So now we're going to talk about kind of another origins topic, the origins of the universe itself. It's the origin of life. So, biology, is it evolved by chance or designed with purpose? Go to the next slide. So, what is biology? I like to quote Richard Dawkins a lot. I know he's a very staunch atheist, but he has a wonderful knack for one, framing the topic, although he usually takes the wrong side. But then he also usually says the quiet part out loud. So, what is biology? Biology is the study of complicated things that have the appearance of being designed with a purpose. So, obviously, the first part of that sentence is not really debated. Biology and life is very complicated. People acknowledge that. It's just, was it designed with purpose, or is it just an appearance of a design, and was it all just an accident? So you go to the next slide. So, apparent design. I mean, one of these things that we talked about is the human body itself. This is just a general overview, and then we'll kind of get into some of the specifics. One, the apparent design that Dawkins talks about, the human body being one, comprised of complicated central nervous systems full of multiple feedback loops, stimulus, which in and of itself is, I mean, in engineering, feedback loops of any type are very sensitive and prone to chaos and oscillation. So the fact that we have these internal feedback loops inside our own body through electrical impulses is kind of an engineering marvel, and how it like that is uh, tuned so precisely to be able to work. We also have these neural networks in our brains that are capable of nonlinear computations, vast nonlinear computations in milliseconds, some things that like computers can't even do. You don't always fully understand like the amount of physics and math that goes into just simply throwing a football, say. Like a quarterback has to throw a football 50 yards downfield at precisely the right time to get a receiver. The amount of math that goes on subconsciously in the brain and with the muscles to do that, computers can't even mimic that. And then also just like a basketball player throwing a basketball into the hoop. So we're finely tuned for these things. It would appear, again, it seems that way, an appearance of. You go to the next slide. Also, we have another example of this apparent design, the miracle of the eye. Something that astounds scientists to this day, the complexity in the eye, the lens being apparently designed again with the laws of optics and physics in mind to be able to refract light just the right angles into the retina. We have cells that act as not only mechanical support for the retina, but also act as what's called waveguides, where they transmit electromagnetic waves and differentiate based on color and intensity back into uh, the nerve endings. They are able to decode that for the brain to see the image. Again, it's obvious that it's complicated. It's just, is it apparent an appearance of design, or is it really design? So, and if that is the case, if it is just an appearance, how would you materialistically come up with this complicated life? How would you materialistically explain the appearance of design? And you go to the next slide. That is what comes into the history or the theory of evolution. We're going to talk just briefly about the history behind evolution, where it came from, how we got to the present theory that we have, because I think it's important to understand the history of things and how we got to where we are. Go to the next slide. So really, evolution, or the history of evolution, is the story of uniformity versus catastrophe. Early on in the scientific Enlightenment period, it was dominated by what's known as catastrophicism. It's the belief that and it originated in geology mainly. It's the belief that most of the Earth's features could be explained by catastrophic events that happened rapidly and were of large scale in the Earth's past. Um, you can see the religious connotations to that. Most of the scientists in the day did believe that the flood was the most recent catastrophe, and a lot of the Earth's features could be explained through that. What started to happen around the Enlightenment period, again, we talked about this a little bit at the last session. Um, During the Enlightenment, people started to become a little disillusioned with the church as an institution. There's a lot of religious infighting, um, Catholics and Protestants. So a lot of people were kind of looking for another worldview, another way of life, and materialism seemed to offer that. And one of the outcrops of that worldview is what's called uniformitarianism. It's the idea that Earth's features can be best explained through slow, gradual moving processes that you see in work and at action today, and that you just use the processes that you see today to explain the past. So you go to the next slide. This actually starts with two men, Charles Lyell, who was a geologist, and before we get to Darwin, he was the one who developed this principle of uniformitarianism. He wrote a book called The Principles of Geology, where he developed this idea. It's called the present is the key to the past. Again, it's to the whole key to that is when you're seeking an explanation for a cause, you invoke, or an explanation for an effect, you invoke causes that you know are able to produce that effect. A simple example: if I lose my keys, I don't say someone jumped, like broke into the house and stole them. I don't say the earth opened up and swallowed my keys. I say I probably just misplaced them because I do it all the time. I've seen it happen. Like, we know that to be the truth, or to be the case. So you invoke these causes that you know to be able to produce that effect. So it's a reasonable assumption, and there's no inherently illogical view there. It's just how far do you take it? Uh, Darwin read the principles of geology from Charles Lyell um, on his now, I guess, famous journey where he sailed around the world and ended up in the Galapagos Islands. And he thought, well, maybe these principles, if they applied to geology, I could also apply them to biological life and could come up with a naturalistic principle that is guiding life. You can go to the next slide. So he wrote his book, Origin of Species, where he used, again, the principles of Charles Lyell to come up with a naturalistic framing that was guiding life. And he came up with two twin pillars, as he called them: the idea of universal common ancestry, the idea that all of life originated from one single life in the long distant past, and that branched off all the diversity of life that you see today. And then the idea of natural selection, which is kind of the guiding factor or natural hand that was forcing this diversity. Go to the next slide. All right. So this is a picture, the tree of life that Darwin theorized about, and this is, again, common ancestry. The very base of the tree, you have some primordial cell or organism that existed eons ago, and over millions and billions of years, using natural selection and what he called random mutation, you could perhaps get diversification. This is the picture that Darwin envisioned, and this is the picture that is um, promoted by most popular evolutionary biologists and what we think of when we think of evolution and what is taught in a lot of high school texts, for example. Go next slide. So natural selection. This is the idea that animals that are adapted to their environment tend to thrive. So it's just essentially a fancy way of saying survival of the fittest. If you're more fit for the environment you're in, you're going to survive and pass those traits that make you like those advantageous traits that make you fit in that environment to your offspring. Um, this is usually Darwin liked to draw analogies of this to artificial selection, which we use all the time. Dog breeding, for example, you can take multiple different breeds that have a certain trait, breed them together. You can keep over successive generations. You get traits that you desired. So you can kind of create a whole different dog breed with traits that you envisioned. It's very powerful in that sense. And Darwin thought, well, if it's so powerful to do that, maybe if you give it enough time, you could produce even more changes, maybe even cross species lines, for example, and produce a whole new organism. Um, and then this picture here is he was studying the finches in the Galapagos Islands. He saw that they had different beak shapes. Some had really thick beaks that were advantageous to crush open like walnuts and get the food inside there. Some had more long beaks that they could dig into tree bark or the earth and get worms for their food. So again, he envisioned different environments might allow different finches to thrive in that sense and pass those traits on to their offspring. Then over successive generations, you only have one type of finch. The problem with that, though, again, the finch is still a finch. It's a bird. The problem, or the what Darwin wanted to figure out is if this was possible to produce new animal form, a completely novel type of animal from what you had prior, or does it have to remain in the species group? You go to the next slide. So now we come to talk about is this a theory or this is if this is the fact. Most people, when you talk to them about evolution, it's kind of assumed it's a fact to the layperson in modern culture. Although, as you'll see in the scientific community, it's not always the case. In fact, there's a lot of contention around Darwin's theory of evolution in the scientific community. But most of the populace don't admit that. As you can see, Richard Dawkins, again, I like to quote him. He says the quiet part out loud. Because it's absolutely safe that if you meet someone who claims not to believe in evolution, that person is either ignorant, dumb, stupid, or insane, or possibly wicked. But he doesn't like to consider that. So it's very nice of him. He doesn't want to say we're wicked. But yeah, so it's often met with a lot of hostility, and a lot of that does stem from the obvious fact that if evolution is not true, naturalistic, materialistic worldview is not the best explanation, then the only explanation left is something of a higher power, and a lot of people don't necessarily like to consider that view. Go to the next slide. So, as I mentioned, in the scientific community, it's kind of, I don't want to say obvious, but it's highly or widely debated that evolution is even a good theory anymore. As recent as 2016, they called a meeting at the Royal Society in London, one of the most premier institutes of scientific thought. They called a conference there, and the whole topic was to debate the power of evolution by natural selection and random mutation. And one of the a leading evolutionary biologists in this field, Gerd Mueller, he actually wrote a pretty good book on evolutionary biology, which he's actually pretty open about it, and he talks about the three explanatory deficits of Darwinistic evolution. One, phenotypic complexity, phenotypic novelty, and then non-gradual forms or modes of transitions. Phenotypic is just a fancy way of saying physical characteristics. So he's saying evolution has not been able to explain is the complexity of physical characteristics between animals, the novelty of different characteristics, so going from one animal form to another, and then also the fact that we don't see gradual forms or transitional fossils in the fossil record. So these are admitted by some of the leading evolutionary biologists. They are aware of this problem and they are actively seeking alternatives to evolutionary theory. That doesn't mean they're coming to Jesus, right? They're just kind of trying to develop other naturalistic mechanisms that they can get around this. But they at least are aware that evolution is not as, um, I would say, as defendable as some people claim it is. Go to the next slide. So we're going to look at some of the evidence. We're going to go through those 3 points that Gerd Mueller pointed to: the complexity of life, novelty of new animal forms, and the false record. Start with the false record because it's so, I would say, jarring. Go to the next slide. So, when we're assessing any worldview, any theory, we have to first understand its predictions. Any worldview makes a claim about reality, about the world we're in, and then how do we know if it's true? Well, we go out and observe the world and see if this theory, this worldview, actually matches what we see. So, the claims of evolution, in order for evolution to be true, you need two things. One, there has to be numerous intermediate fossils because if evolution actually did happen, you would have immense, multiple gradual, intermediate, transitional forms. That's the whole basis of the tree of life, for example. And the fact that this happens over a slow, incremental process, as Darwin defined, it had to have happened that way. You would have multiple intermediate forms, and if it's so slow, it would have to happen over eons of time. So two things: multiple intermediate fossils, and then gradual progression over time. Those are the two things that evolution is based on. So, what happens when we look at the fossil record? Well, the most jarring thing, known as the Cambrian explosion, is at the very lowest strata of rock that geologists have uncovered. At the very, you could say, dawn of life, you get this explosion, sudden appearance of animal life without any prior intermediate ancestral forms. So you can see in this figure at the bottom part of it, you get kind of like this, what Darwin and evolution would expect, this branching tree of life. But when you look at the fossil record, you don't see that. In the Precambrian era, you don't see any of these what are called intermediate or ancestral fossils. You get a little bit, some fossils of animal life during that time, but they correspond to a specific, I would say, animal group, and then they remain in that group through into the Cambrian. What happens in the Cambrian is a sudden explosion of life, multiple animal forms of complex nature, and then you see them as they continue through the geological record, they remain in those already defined animal forms. You don't see this branching out into other ones that remain in their kind of kingdom or order that they've been put in. Um, so this is huge. This kind of goes um, counterintuitive to the evolutionary theory, goes directly against what an evolutionary biologist would expect to find, um, and has yet to be fully, remains to be explained, I guess. You go to the next slide. So an example of this complexity, like even the animals that we see from that beginning are very complex. An example of this is what's called the trilobite. Um, a marine aquatic creature would, I guess, they would crawl along the seafloor. These are already complex organisms. They have a fully formed exoskeleton. They have a nervous system that we talked about already. Has complex feedback, electrical stimulus. They have compound eyes that modern creatures still have to this day. There's been no evolutionary change over that. Compound eyes are of incredible complexity and precision. They form multiple superimposed images for the animal to view. Um, and uh, yeah, and the fact that this existed at the very beginning of life, that we didn't have to work up to this point as they claimed over millions of years just to get, for example, the eye, as evolutionists claim that you start with some small photosensitive uh, point that eventually evolves over time into an eye. No, from the very beginning we had eyes, compound eyes that worked just as they do today. Um, so this is stunning and still is unexplainable through an evolutionary eye. You go to the next slide. So this wasn't an unknown problem even in Darwin's day. Darwin himself admitted that to the question as to why we don't find rich fossiliferous deposits belonging to these assumed earliest periods before the Cambrian, he could give no satisfactory answer. He had an answer, but he himself didn't like it. His answer was the fossil record was incomplete, and we'd have to go out and find more fossils. If they were out there, we just hadn't found them yet. A lot of people of Darwin's day didn't like that answer. It was more of arguing from a negative position. It kind of takes the blame off of you. Even some of his colleagues at the time were very, very vocal about this. As one of his colleagues, Adam Sedgwick, wrote to him a letter in which he said, "You have deserted after a start in the path of solid physical truth, the true method of induction. Induction is just how we reason in science, evidence-based reasoning." So this was known in Darwin's day, but he just thought we would fill it in as we went out and found more fossils. So go to the next slide. So this kind of remained both in that day and to this day. It's called the artifact hypothesis, which is that the lack of intermediate fossils is just an artifact of one, incomplete sampling, or two, that the earliest forms of animal life are soft-bodied animals. Didn't have these hard exoskeletons, so we didn't get, and they were not as well preserved in the fossil record, which is true. Soft-bodied animals don't preserve as well in the fossil record as a hard-shelled exoskeleton animal, for example. But we'll see that that doesn't really help you in this case. Go to the next slide. We have, even though it's true that soft-bodied animals don't preserve well, they don't make fossils as well as hard exoskeleton animals, we still have plenty of fossils of them. We have fossils of jellyfish. We have fossils of sponges. We have fossils of sponge embryo, and even cells of bacteria from before the Cambrian era. So the claim that, well, we won't be able to see these transitional fossils because before you get to the hard skeleton Cambrian era, we have soft-bodied animals, and we're not going to see them. We have plenty of evidence, even in the pre-Cambrian era, of embryos of sponges, cells, bacteria. We have fossils of in which you can see cells in the middle of dividing themselves. So that doesn't help you any because either and the fact that this would have had to happen over millions of years, you would see something. If we were able to see some fossils of soft-bodied animals, if we give it millions of years, we would see the transitional fossils. So after some of these recent discoveries, most paleontologists have rejected the artifact hypothesis um, for this for these reasons. Go to the next slide. And as far as the idea of incomplete sampling, um, since the time of Darwin, over 150 years ago, we have found even more what they call as deposits of fossils, just areas on the Earth or around the world that have rich fossils that you can go uncover. Two big ones, the Burgess Shale, and then another one in China. I don't know how to say that name, the Shan Shale. But either way, more fossils were uncovered, but the only problem is it only increased the number of complex animals and diverse animals that existed in the Cambrian era. Nothing discovered before that, no transitional fossils. And it was so big that Time magazine even wrote an article about this in 1995, calling the Cambrian era evolution's Big Bang, which is kind of a funny term to use because we talked about last time how the Big Bang is evidence of the beginning in the universe, and that implies creator. So there, you're saying there's this Big Bang of animal life. Well, if animal life arose naturalistically, it has to be slow and gradual. Now you're saying it happened suddenly. That applies something must have known what it was doing, right? Because evolution by nature has to be blind, has to be random. Blind, random processes act very slowly. If you do something by leaps and bounds, it's because you know where you're going. You know what you're doing. Uh, so this is was as you discovered all these different fossil deposits, it was huge, and um, yeah, it only goes to prove the fact that animal life arose very suddenly and in a complex arose with complexity in it already. Next slide. The other thing this does is it takes away the time element of evolution. Because if you look at the different layers of rock and you go between the Precambrian era to the Cambrian era, you get a gap for the Cambrian explosion to happen of only 5 to 10 million years, which seems like a long time, but geologically and evolutionarily speaking, this is a blink of an eye. Because they've done the math as far as population genetics go. Population genetics is a branch of evolutionary biology to give it a mathematical background, kind of give it a mathematical basis like most science have. And they've gone through the math of how long it would take just to get two coordinated mutations, which is very important because you need coordinated mutations. Otherwise, you have one mutation going one way, another mutation going another way, they counteract each other. So to get two coordinated mutations, it takes 216 million years. And the Cambrian explosion happened over a gap of 5 to 10 million years evolution over geological time. So, and it takes a lot more than just two mutations to build a whole new animal. So the fact that this Cambrian explosion has shrunk the time for evolution to even happen is huge. Um, yeah, you can go to the next slide. So now we have to ask ourselves, where do we want to? Are we going to let ourselves follow the evidence, let it take us where we want it, where it's pointing to, or are we going to stay kind of almost in this religious dogma of what we're going to allow ourselves to think? The scientist J.Y. Chen, he was one of the paleontologists that discovered one of the big fossil deposits in China that um, that only proved or went to show that Cambrian explosion was as big as it was. He gave a talk about this at the turn of the century in 2000, and he was questioned by a lot of his colleagues, saying, "Aren't you kind of afraid of saying that this discounts Darwinism, coming as you do from a very authoritarian country?" Which he responded with, "In China, we are allowed to question Darwin. We just can't question the government. But in America, you can question the government all you want, but you just can't question Darwin." So it's kind of a funny way of looking at it, but in a way it's very true that oftentimes in the scientific world, big there's very much a dogma around certain worldviews that we're not allowed to question. Um, but we have to let the evidence follow where it's pointing, or we follow the evidence where it's leading, and that's kind of what he was talking about. Go to the next slide. So next, we're going to talk about the next part of those points that Gerd Muller pointed to, the appearance of complexity in nature and how evolution is not able to explain all that complexity. Before we do that, after going over the fossil record, I kind of want to take a break. And if there's any questions about that, we can talk about it. We can give like maybe 5-10 minute break, have a little discussion. You guys can walk around if you want. Sometimes sitting through the whole lecture can be hard. Yeah, if there's any questions. Well, I mean, they often say we came from monkeys because we seem so similar, right? Like anatomically, um, our DNA is similar in some sense, to a certain extent. Um, which, biologically speaking, just because there are similarity doesn't imply causality in any way. You have to look at one again. Is it shown in the fossil record? And if evolution occurred, if we evolved from chimpanzees and monkeys millions of years ago, there would be multiple instances of evidence of that. It's not enough just to have one or two supposed missing links that you kind of claw together from bones and fossils or on a hillside that aren't even together. Some missing links are very and I would say, yeah, disputed. But yeah, even if you have a couple of supposed missing links, that's not enough. If evolution happened, this occurred over millions and millions of years, and you have multiple instances of that. It would be obvious. You would see a myriad of ape slowly transitioning into a human, and we don't see that. And again, the convergence, supposed divergence, divergence of chimpanzee and humans, um, again, is only a gap of a few like million years ago or so. And then again, you talk about you need two coordinated mutations takes 216 million years. So even that, the math just doesn't add up. Um, so just because they're similar doesn't mean you can easily explain similarity also with design, the design argument. You use similar designs over multiple. So similarity doesn't infer causality. Yeah, right. And Absolutely. Yeah. Yeah. No, definitely. And I don't think with what Jonas was saying, Darwin. Yeah, Darwin himself never said we came from monkeys. His idea was just the origin of life came from the same universal life at the very beginning, and then branched off into multiple. He didn't claim exactly where that went. He just that was his theory of what happened, and then was guided by natural selection. Although it is true, a lot of people nowadays will say that we did come from monkeys. I think that was more what but certainly that wasn't what Darwin himself was saying. But yeah. So no, I don't think the Bible was written to be a science book. I think when you do science, it oftentimes lines up. It doesn't dispute the Bible. Uh, but the Bible says a lot of things that aren't scientifically minded, right? And the gospel and, morality and all that, that has nothing to do with science. But science has never. I don't think science disproves the Bible. I think the science only affirms the message and story told by the Bible. And as far as uh, if the story in Genesis is a story of God creating or guiding per se evolution and creating life in that way, that's still debated among scientific Christians. My personal stance on that is that I'm personally a young creationist. I do take issue with some of the ways that they measure rocks, as far as like radiometric dating. Um, but I know a lot of respected people that are old Earth creationists, and that's fine. I take issue also with the fact that if God did create us, a main mechanism of evolution is death. Right? You evolve and die over millions of years and the next form of life. Yeah, that could be guided by an intelligent mind, but then you have to also talk. It goes into where Paul talks about death only came into the world after sin. Um, so I find that to be a kind of conflicting message. Um, if it is the way that God did it, I don't think it's necessarily an issue with the gospel. Well, I guess also in the gospel message it is about redeeming from death. So yeah, um, that's my stance on it. I know a lot of respected people that might lean another way. Um, so some people do. I don't take that stance. I take the stance uh, that we were created without the process of death. Um, I would think so. Well, that's a hard question. That's a great question. I'd have to think about it a lot, but I think my gut instinct would be that if death was used in the process of making life, it kind of goes against the idea that we were made in the image of God and that life was good in the beginning and that death only entered after sin, and then we need redemption from sin and death. So that's my take on it. I think it would go against that. Yeah, great question. Love those. Any more? Yeah, definitely. Yeah, there's like 17 other explosions in the history of the fossil record. Um, so yeah, there's definitely other instances of that, and just keeps so much so that one famous evolutionary biologist, Stephen Jay Gould, he came up with a term called punctuated equilibrium to explain evolution. Where evolution occurred in stages where you have stasis for a period of time, which there's no it's just animal life, and then rapid change, animal life, stasis, rapid change, stasis. It's like a staircase effect. Again, you have to explain how that, if that was what happens if mutation suddenly quickened, for example, during that time to account for that. You have to give a mechanism for that, which he was never able to do. Why would mutations quicken during that time and then stop and then quicken again? Um, and yeah, so that, I mean that's the whole story of the fossil record is these random explosions of life, um, and not a gradual appearance of life. as Darwin. Other well, we can go on to the next section unless people want to walk around for a bit. Good, everyone's good. Awesome. All right, so we'll talk about the cell. All right, go to the next one. So, a challenge from Darwin himself. He said, if it could be demonstrated that any complex organ existed that could not possibly have been formed by numerous successive slight modifications, then my theory would absolutely break down. But he then went on to say, I can find no such case. Um, so, back in Darwin's day, they knew of the cell and they knew it was complex to a certain degree. I don't. They certainly didn't understand how complex it was, and it also the depth of that complexity. So you go to the next slide. Because obviously, with evolution, we don't have to start. At least in Darwin's mind, we didn't have to start with a complex animal to begin with. We can start with a simple cell, and over time, that simple cell can evolve to produce more and more complications. We can easily explain the appearance of design through that. But so we'll just talk a little bit about cell theory. We won't go into too much details of it. But cell theory, three main points. The cell is the most basic unit of life. All living organisms are composed of cells. And the other third point, all cells arise from pre-existing cells, which is kind of a funny thing to say in biology when the whole point of biology is to say that life came from life. But it is one of the principles in cell theory. And they've added more to it since then, but those are three main tenets or those 3 points are the core beliefs of cell theory and biology. Go to the next slide. The first life. Darwin himself admitted that his theory of biological evolution is not intended to explain the first cell. That is a challenge for what's known as chemical evolution. He kind of wrote about it and said that it was you can conceive of naturalistic processes in some primordial soup. He called it, where maybe you get some electricity and you can get chemicals congeal and over chemical processes would form the first life. His biological evolution assumes and necessitates life to already exist to even operate on. Because in order to have random mutation, you need life to mutate. Natural selection operates on that random mutation to push life in a direction. So that was not his intent. Uh, Chemical evolution is an interesting topic. I might give another talk on that because it's also fascinating how, chemically speaking, you can never get the first life. But I'll give him, we'll just assume there's a cell. All right, you go to the next slide. The problem is, this is quote unquote the simple cell. It's not as simple as some people used to believe. The cell is made up of the factory mainly. It's a factory made up of molecular machines at the atomic level. You have some proteins that act as molecular motors that push and move the cell around. You have some that do solar powered energy conversion storage. You have some that act as assembly lines, highways. You have cells that literally form roads through, or some molecules that form roads through the cell to transport other material across. And as it's transporting it, the road breaks apart as it goes because if it remained, the cell would become too rigid and it wouldn't be able to move around. These roads form automatically and then deform after their purpose has been done. You have manufacturing machines that transcribe and translate information to make proteins. Proteins are the tools of the cell, and proteins, their function is based on their three-dimensional shape, which is fascinating. Proteins actually fold into different shapes based on how they're arranged, and their function is based on their shape because they fit together for certain purposes, like a wrench, or a hammer, or anything like that, or gears in a machine. So this is important to understand because this is what you have to start with. Um, and the fact that it is as complex as it is, you mentioned earlier about it. You walk into a cathedral and you don't just say, "Oh, it's amazing how sand and erosion built these stained glass windows." Uh, this obviously screams of some type of design. Um, so even when you look deeper and deeper into the cell, you realize its rich complexity. The more you look into it, you see more and more complexity. You go to the next slide. Go to the next slide. I think there's one more before this. There's another one before this. This is also uh no. Well, go yeah, that one. All right. The single cell bacteria, uh, not quite as complex as the cell I just showed before. That cell is what makes up humans, animals. Is called a eukaryote, I believe. Eukaryote cell. These are prokaryote cells. Single cell bacteria. They're like, well, this is simple, more simple than the other cell, which is true. There's still a lot of molecular machines that go on here. You have manufacturing ribosomes that translate and transcribe DNA for multiple functions. You also have DNA itself that exists in the cytoplasm of the cell. Um, and then you have these little kind of arms that flail about and help it move. But maybe we could start here with life and explain that life arose from single cell bacteria. Only problem is, go next slide. Yeah, bacterioflagellum. Fun little word to say. But it is the motor that the bacteria uses to move around. And if you look at it, it looks just like an outboard motor that you might see like on a boat. You have a filament propeller that rotates around. You have a universal joint or hook that helps it attach to the bacterial wall. You have bushings that allow it to go into inside the bacterial cell wall. You have these C-rings, stators, and studs that help move electrical current around that motor to turn it at speeds thousands of rotations per second, and it can stop like on a dime and rotate the opposite way in like a fraction of a second. It's fascinating. It's immensely more efficient and precise than any machine we've devised today. Um, so even at this level of a bacteria single cell, you have immense complexity of what looks like machines working together and gears coordinating proteins and molecular machines that act together. Um, and what's interesting is that as scientists have studied this, they realized a crucial thing is that if you remove any one of these proteins, molecular molecules, the machine doesn't function. It's not like it doesn't just work, but work poorly. It just doesn't act. It doesn't function at all. So then the question becomes, well, how can this arise evolutionarily speaking? If it has to be slight modifications, add things, change it over time, when this doesn't even function until all the parts are there. So that's a huge challenge, uh, Darwin's theory, and it's called what's known as irreducible complexity. If you go to the next slide. Irreducible complexity is the idea that any system composed of several interacting parts are necessary to its function, without which, without any one of those parts, it won't perform that said function. A common simple example is the mousetrap. You have just the wooden board. The function of a mousetrap is to obviously trap mice, cap, or catch mice. Wooden board by itself isn't going to do anything. You have the holding bar, it's not going to do anything. You have the hammer, spring, it's not going to do anything. You need all of them there for this to perform the function that it's intended to do. And they say this, they see the same type of design in the cell, in the bacterial flagellum, for example, and other areas of the cell. This presents a huge challenge to Darwinian evolution. You go to the next slide. There are other such examples of what's known as irreducible complexity. Bacterioflagellum is one. Eukaryotic cilium, those arms that you see on the cell, they have similar irreducible complexity. Without one of their protein molecules, it wouldn't function. Ribosomes that do the copying of the DNA, calcium pumps, um, known as kinesin motors. Blood clotting is also a huge one. Think about it, blood clotting has to happen at the right time. If it happens too early, blood clots aren't meant to be there, which we all know are very bad. You get strokes from that. Blood clotting has to happen at the right time, and after the blood clots around the area, after it performs its function, it needs to go away and dissolve in the right manner. All this is based on protein molecules that act in concert with each other and with precision, without which any one of those proteins, blood wouldn't clot. They've actually ran tests on this, kind of messed up, but they've ran tests on this with certain breeds of mice where they are able to eliminate certain genes in the mice that allow for blood clotting. They remove one gene, and the mice aren't able to blood clot anymore. So they die very quickly from cuts. And then another one, they remove a gene where that doesn't allow for the blood clotting to go away, and again, they die. Its mortality rate is very high, so they're not even able to survive to reproduce. So the fact stuff like this provides examples of how would this occur over evolutionary small changes when you need the whole system there to even function. This gets to a kind of a more logical, philosophical point with evolution, because the whole idea of evolution is you're going from function A to function B, um, and you get there from slow moving steps. The whole point is that at some point in the process, you're not going to be as good as you are at function A. You're not going to be as good as you could be at function B. You're going to be in the in between phase. And so, in the in between phase, you're not going to be really good at anything. So, why would natural selection select that to keep going? It doesn't confer a functional advantage. That's the whole point of evolution. It needs to have an advantage for natural selection to push it on. But if you're in between those two functions, you're not going to be good at either one. And natural selection will more than likely select the one that already knows what it's doing, the function A. So you're never going to be able to move forward. The only way you can do it, again, is in leaps and bounds if you know what you're moving to. You have to, this kind of gets into engineering, and I see this a lot when I do. If you're adjusting a circuit, you adjust one portion of it, one small part of it, that affects a bunch of other areas of the circuit. And so you have to go in and tune every other part of the circuit to account for that one change you made. But evolutionarily speaking, how does that happen? Because there's just one random mutation in the design without thinking of the repercussions that it puts on the rest of the system. So logically speaking, I think that the philosophical gap in evolutionary theory, but it's shown in the actual complexity in the cell. Go next slide. Okay. Before we go on to this topic, are there any questions? Question? All right. All right. Cool. So now we're going to talk about a bigger problem, uh, origin of information. Go ahead to the next slide. So for a long time, biologists knew that some traits are hereditary. They get passed down to the offspring. That's the basis of evolution. We see that in life all the time. But what was unknown is how that functioned. Where was the Where were the traits stored at? How were they given to the offspring? How did this make its way into a final physical expression? That was something that was up for debate. Next slide. So Watson and Crick made this discovery with what's known as the DNA molecule, and Francis Crick, who's actually a code breaker, interesting because not only did he was he a code breaker during then, but he also realized while studying DNA that the DNA has a code to it. It's a 4-digit code that information can be stored on, and he theorized that that's what, and was later confirmed that that's how information is passed down to offspring, how you determine physical traits, how you even build biological and molecular machines inside the cell is based on this information stored in the DNA. But I mean that what they began to realize is then information is at the heart of all life. Language is at the heart of all life. Something is telling these cells how they're able to function, what they need to do. There's a blueprint, instruction manual. Go next slide. So, what is DNA? All right, I'll try to go through this. I don't want to go into too much detail, but DNA, two main parts. There's a helical backbone that spirals down, and then you have this kind of ladder-like network that goes up it. The ladder network is made up of 4 nucleotide bases that can be arranged and fit together along the backbone of the DNA molecule. And information can be conveyed based on the sequence of those nucleotide bases. It forms kind of a 4-character alphabet. Um, Depending on that sequence, it conveys some type of instruction. Go next slide. So big thing that you use DNA for is in protein formation. Again, I mentioned earlier, proteins are the tools that the cell uses to perform all of its functions. The body uses proteins for all of its functions. These are the tools. You need protein to have life. So in DNA, you have these sequences of nucleotide bases that are encoded. You have a mRNA, messenger RNA, that literally transcribes one side of that DNA onto a separate molecule. It's like you're transcribing a code into a piece of paper. That messenger RNA gets sent out of the nucleus, like you're sending a messenger with a piece of paper out to this manufacturer ribosome station. That ribosome knows that certain sequences of amino acids are correspond to, or certain sequences of nucleotide bases correspond to amino acids. Amino acids are uh, I guess they are the building blocks of protein. So ribosomes take certain sequences of these DNA molecules. It says, okay, this corresponds to amino acid A. This one corresponds to amino acid B. It lines them all up, forms a protein molecule, sends it out to another um, molecular station that encloses the protein molecule and folds it up in just the right way for it to operate. So DNA is crucial in this. All the information is there, and it's an instruction manual for which ribosomes and all these machines build proteins. Go next slide. So then this becomes one. Slide, but one, you have to think about, where did the first piece of information come? Information is what guides protein formation. Protein formation is what allows the cell to do all of its functions, allows it to even divide itself and reproduce. Before you even had information, how does the evolution work? Because there is nothing that's guiding, no information that's telling the cell what it does. And a lot of evolutionary theories have postulated multiple different ideas, such as like RNA world, which is RNA, half molecule of DNA. Maybe that was the precursor to DNA, but RNA still has information on it. And so you're just kind of kicking the can down the road. Before you get to RNA, you have to explain how you got to where you are without any information. So, but once you have information, again, I'll give you the DNA, I'll give you the first cell. Once you have that, the challenge now becomes how do you make a novel animal form? How do you make new life? The only way the evolutionary theory can do it is random mutation along the DNA molecule to produce new information. You have to go from one animal form to another, and in order to do that, you need new information. So the only way to do that, randomly mutate the sequences in the nucleotide bases on the DNA. The problem with that is this process is purely undirected. Again, it doesn't know where it's going. It doesn't know, has no goal in mind, and it doesn't know what went wrong. Nature doesn't keep a notebook. So even if it is mutating things, it could do the wrong mutation over and over again, over millions of years. And again, uh, experience has told us that random mutation to any digital code, if you work with computers, engineer, you randomly start changing ones and zeros, it's going to only degrade the information you have. There has never been an instance where you randomly change information and you get a new information, you get new intelligible information. It always degrades. Go next. Murray Eden. This became known when Watson and Crick discovered the DNA molecule in 1953, and then they realized that it had information in it. In the 1960s, they called a conference at the Star Institute, I think, at MIT, a lot of computer scientists, computer engineers, discuss the theory of evolution with biologists because they recognize that if you're saying that there is a code at the beginning of life, that there's a code that directs life, then this doesn't add up. Because Murray Eden, one of the speakers at that conference, again said, no currently existent formal language can tolerate random changes to its simple sequences, and which express sentences. Meaning is always destroyed. These computer scientists recognized the problem, and the conference was known as mathematical challenges to the theory of evolution. So this was known even in the 1960s. So again, evolution is always presented as this rock solid fact that you have to believe, or else, as Dawkins says, you're either an idiot or you're wicked. But even in the 60s, people were recognizing problems with this, and again, even now, scientists are understanding that there's a lot of deficits to the theory of evolution. And the point of all this is not to necessarily say, I mean, we believe very differently than naturalists, but the point of these arguments is not always to say it's definitely this way, but to say it might not be what you think. No, you don't have to fully disprove it, but you have to say, listen, you think it's rock solid, you think it's impenetrable, but there are a lot of problems that people acknowledge with that theory. So A lot of people, they just go on the basis that everyone agrees it's true. But so now we're going to talk about what's known as the combination problem. So goes into the mathematical challenges to producing new information. Um, there's actually a way you can characterize how well a random search will operate. Uh, there's three things you need to know. One, the total size of all possible sequence arrangements. How many different ways you can arrange a sequence. Two, the size of meaningful sequences. How many different arrangements actually convey information, actually convey meaning, or is it just gibberish? Then three, how many opportunities do you have to sequence it or search that space? These are the three big things you need to know. And then depending on the answers, you can actually say, oh, is it more or less likely that a random search will be able to find a meaningful sequence? Go to the next slide. So I'm going to use an illustration for like a bike lock. Say you have a 4-digit bike lock, and you're trying to break the code for that bike lock. There are how many different possible arrangements? 10 to the fourth power, or 10,000 different possible ways of arranging those codes. There's only one right sequence. So if you do this every 10 seconds, if you search a new combination for every 10 seconds, don't take any breaks. And after 15 hours, you would have sampled around 50% of the possible combinations. After that, you could actually say, well, a random search might actually get you the correct answer because now you're halfway there. So this is one way you could say, okay, well, random searches sometimes might be more likely to succeed after a certain amount of time. You go to the next slide. So then let's say, okay, let's try 10-digit bike lock. In this case, you have 10 to the 10 power, which is a big number. I don't even know what that is. In this case, if you sample a new combination every 10 seconds, then after 100 years, you would only explore 3% of the possible combinations. So then you could still say, in this case, it's very unlikely, randomly searching, you're going to find the right code. Um, then this becomes a question of DNA. And people have actually gone through this math of figuring out how many different combinations create meaningful sequences in DNA that can code for a new protein. Go to the next slide. Um, so depending on the sequence, it codes for a protein. How many of those sequences actually give you a meaningful protein? They've done analysis on this, and one scientist, I forget his name now, but he took a protein fold, a very modest sized protein fold consisting of 100 amino acids. The ratio of functional sequences to non-functional sequences was 1 over 10 to the 77th. So non-functional, non-meaningful sequences, 10 to the 77th. Just to give you a perspective of that, the estimated number of atoms in the universe ranges from 10 to the 78th to 10 to the 82. So this is staggering number of possibilities. Just for a protein consistent of 100 amino acids, to give you context for that, hemoglobin, which is a protein that makes up blood, consists of 574 amino acids. So the odds start to get very, very staggering here. But that's just one aspect of it, right? One, again, we talked about, is a random search likely to succeed? One thing you need to know, how many, the ratio of functional to non-functional sequences. The next thing you need to know is how many opportunities you have to search. Go to the next slide. So how many opportunities do you have? This is expressed in number of trials, the number of organisms, how much life has there been, chances to mutate a DNA. They've actually done the math on this. The number of organisms in the history of Earth is on the order of 10 to the 40th power. Then you can, okay, do the math. Number of sequences to be searched, 10 to the 77th. Number of trials, 10 to the 44th. If you have a replication event, or after every replication event, you do a mutation to search the sequence pattern of amino acids, you would only have searched 1 over 10 to the 37th power of the possible sequences that exist out there. So this is just for one protein fold that consists of 100 amino acids, very simple protein fold, and you need more than just one protein to build life. So even after the whole history of life, you've only searched 1 over 10 to the 37th. The odds of random mutation finding this new functional sequence from the first life, if we just give it the first life in DNA, is staggering. So this is the problem that they realized at the Wistartan conference of mathematical challenges. But the math isn't adding up. It's almost impossible. Even if we were to give you all the time in the world. That just one protein. So doesn't add up. Your next slide. Okay, we're gonna talk about how to build an animal, evolutionarily. This is the last section. Any questions on this? Yeah, so in order, because the whole basis of evolution is you get new animal forms. The only way to get new animal forms is to have new protein structures to build those new animal forms. The only way to get new protein is to get new sequences on DNA, because DNA is the instruction manual to build these proteins. So in order for it to say, "Hey, build a new protein," you have to have a new set of sequences. So then the question becomes, how does that happen? 'Cause, I mean, naturalistically speaking, what's going to change the DNA? The only way that they have is a random mutation. Anything other than random mutation would imply a purpose or a design aspect. You can get certainly environmental factors can push certain organisms in a direction. That's what natural selection is based on. What they've seen though is natural selection acting on that. That is actually one of the things they have. Environmental factors would produce new information, but what they've seen is it's not the environment that's producing new information. It's information that's already in the DNA is getting expressed, and then the environment is just pushing the organism into that direction. The information already existed in the DNA and is present in terms of its diversity of life. And it's just the environment will push it more towards that side. So the information is already there. They realized it's just gets expressed and selected by nature. So nature is not producing new information; it's just acting on information that's already there. Right. Right. Sure. So if you know, kind of, you come into it from an intelligent person coming in, be like, okay, I've done this before. I know kind of maybe there's certain codes that people usually use, or maybe like you, there's a way to like listen on like the mechanism and figure out what code works. Yeah, but then again, that implies some type of intent or intelligence. But that's what they want to avoid is from a naturalistic perspective. Right. Right. Yeah. Right. Exactly. Yeah. That's a good point. Yeah, Roger. Yep. Right. Absolutely. Exactly. Yeah. Again, because the whole idea of natural selection and random mutation from a naturalistic perspective is that it's completely unguided, random. It doesn't keep a notebook. It can choose the same wrong sequence over and over. It has no idea of what it's doing. It has no goal in mind. The evolutionary biologists seem to think that nature was predestined life was predestined to live or to thrive, but that again implies that there's a goal in mind. They don't have an answer for where that goal. Right. Yeah. Yeah. Again, this is, and also the other thing to think about is this is just a single mutation. It's one mutation at a time, and then that mutation must then must keep that mutation to the next generation for another mutation. You don't see mutations of multiple like sequences happen at the same time, and you need to get a coordinating mutation, which is also incredibly hard to do. Yeah, this is again the math just doesn't add up for this to happen randomly, and more likely that life is. So, another okay, go over the last section. So how to build an animal. So how to build a new animal. So if we give you one animal form, how evolutionarily speaking do they say another new novel type of animal is created? Go to the next slide. This gets into developmental biology. Um, so we talked about DNA making proteins, proteins serving as the tools in the cell, and you have different organs in a body, or an animal body, for example. But this doesn't form a functional animal, actually. You have to have a higher level of information that tells the proteins how to interact with each other. It's the same thing as saying if you have a computer or if you have a circuit board, you have these capacitors, resistors, different components on that board. You have to arrange them. You can't just throw it blindly. You have to arrange them in the right pattern and have them interact with each other in the right way in order to form life. They must be arranged and coordinated to form different tissues, organs, and overall body plan. So go to the next slide. This happens in uh, embryo as a fetus is developing. It's known as cell differentiation. They've studied this that after an egg is fertilized, it starts splitting into different cells and cells. And at a certain point, they need to start differentiating, meaning some cells become muscle cells, some become skin cells, some become intestinal cells, nerve cells. Each have different functions that they play, which means they each need to make different types of proteins. The question is, how do they know which one to become? How do they know which cells to differentiate into and make those proteins? There's actually um, regulatory genes on the DNA molecule that codes for specific proteins and times their expression in the cell. And protein communication signals are sent between cells to let them know which cells differentiate into which one. And okay, I'm differentiating into muscle cells. You guys need to differentiate into this cell. Don't do it. Don't do muscle cells because we're already doing it. So there's this immense amount of communication, information flow between all the different cells as this embryo is growing, and it's just beautifully coordinated to allow for life to grow. Next slide. So then timing is everything. In order for significant change in animal forms to occur, you want to build a new animal form, you want to add a new form or a part of an animal, you need to change the differentiation process. You need to mutate a gene that gets expressed in the early stages of the animal life. If you start mutating genes that get expressed later in the animal life, the overall body plan of the animal has already been determined by the genes that came before. So at this point, it's just, in other words, DNA expresses certain parts of its information at certain times. The beginning of the life, it's laying out the blueprints for, okay, this is how the animal, the overall structure of the animal is going to form. This is what it's going to be. A dog. It's going to have these functions. Yeah. Then as the embryo grows, later expressions of information just do the minute details in that follow that overall body plan. Start mutating things down the road, you're never going to get a new animal because the overall body plan has already been defined. So if you want to get a new animal, at some point you have to mutate the early gene expression. But that's the best chance you have at generating a new body plan. The problem with that, though, is that the earliest stages, you start mutating the earliest stages, and they've done this on like flies, then what you inevitably get mutations with global effects that leave the specimen completely uh, non-functional. So, in other words, the mutations at the beginning of the embryo development process are the exact ones you need to occur in order to change an animal. But once you do that, it actually kills the animal. It's only ever been observed to result in the death of the specimen. Um, and the reason for that is because you're changing such a fundamental quality of the organism, and you're not, again, random mutation is only one thing that's changing, and you're not accounting for all the other effects in that information. The rest of the cell is trying to differentiate into this dog. So you're changing one thing at the beginning to say, no, we're going to make some random like wing on it. But that's not what the function is meant for. So it's just um, becomes non-functional. And they did this with flies. They were able to add new wings to the fly actually by changing a gene. At the very beginning of the developmental process, they added additional wings to the fly. But the problem is the wings were non-functional. They just sat there because you didn't change other genes to allow for the support of the wings. So they were dead wings. The fly couldn't even fly and ended up dying. So fly couldn't fly. But so these are the things when you're looking at these regulatory networks. Go to the next slide. These are what they're called, developmental gene regulatory networks. And it's an intricate flow. That what you see on the right is a flow of information. It actually resembles a circuit card where instead of flow of electricity, it's a flow of information that coordinates all these different differentiation of the cell types in the embryo's developmental life. So you change any one part of that, this highly integrated system is very sensitive to change. If you change one part of it, you have to change multiple other facets of it to account for that change, to make sure that it can function. Um, Slight modifications don't work. What you realize now is if you're going to make a new body plan, you actually have to change the whole thing at the same time. You can't just do it slight successive changes. Go next slide. So Eric Davidson, he was one of the developmental biologists that discovered gene regulatory networks, and he realized how interconnected they are, and he came up with this quote: uh, whole network partakes of a quality that there's only one way for things to work. Indeed, the embryos of each species develop in only one way." So realizing that all of life, every embryo is defined with a purpose to go in one specific direction. You start changing just tiny, slight modifications in that developmental process, it results in the death of that specimen, which is exactly what you need to do. You need those changes to occur for evolution to happen, but you need the specimen to live and reproduce to put those changes onto its offspring. So now we talk about inference to the best explanation. So given all this evidence, we've talked about the complexity of life, talked about the integrated information flow, irreducible complexity, non-fossil, non-intermediate fossil types. Um, we can go back to what Charles Lyell himself talked about, which is the present is the key to the past. In order to, when you're talking about um, remote past effects, you have to invoke causes that you now see in operation. We don't see random mutations, random changes generating new information, complex things, or a new animal form. We only ever see one thing produce new information. That's a mind. Even using Charles Lyell and Darwin's own principle of reasoning, our best inference would be a mind behind the generation of information, behind the origin of life. Um, so, given all the evidence, we have to ask ourselves which theory makes the most sense. Go next slide. Then we come to Isaac Newton. Big fan of him. He has some good quotes. He has this one: "How came the bodies of animals to be contrived with so much art? What ends were there several parts? Was the eye contrived without skill in optics, and the ear without knowledge of sound? And these things being rightly dispatched, does it not appear from phenomena that there is a being incorporeal, living, and intelligent?" Again, he made these arguments from the very beginning because he actually studied the eye and realized that it was designed with physics in mind, and and realized that all these design arguments in nature pointed to there being a designer. So that's all I have. Um, questions about this section? No. Thank you. I don't know yeah, any questions about that part? Or overall? Yeah. Um, yeah. This one I took a lot of information from this guy named Stephen Meyer. He's one of my favorite authors. He's head of the Discovery Institute, Intelligent Design. He wrote a book called Darwin's Doubt, which talks all about this, the Cambrian explosion, new information, origin of information, all that. I mentioned on our last Apologetics talk, his other book, The Return of the God Hypothesis. He talked a lot about like the physics of astronomy and how that points to a beginning and therefore a creator. His Darwin's Doubt book talked about evolution and the origin of life. So he's a great resource. Discovery Institute in general has a lot of good resources on that because they like to promote the idea of intelligent design. It's a non-religious idea because there's both Christians and even like you have Muslims, that would say that they are proponents of intelligent design. Intelligent design is just the idea that there is a mind behind it. There is an intelligent being that created the world, created the universe, and then created life. Um, a lot of them are theistic Christians, but yeah, they do great. They do podcasts that talk about this. They have YouTube shorts that talk about it. There's like a newsletter that's called Evolution News that they talk about it. I think they use the word evolution news to make people think, oh, is this about like evolutionary theory? Really, it's about how bad it is. So it kind of gets people into it, and then they talk about the facts of evolutionary theory. So yeah, all that they're good resources. That's what I used a lot, and I used a lot of Stephen Meyer's talks and his book to provide a lot of that information. So none of this was like my own, but yeah, but yeah, it's good. Yeah. Most of it is they say, well, most of the time it's agreed upon that evolution is true. The scientists say it's true. That's what the number one thing that I have to always remind them that a lot of scientists these days they are very skeptical of the theory of evolution. Again, it's not like they're coming to Jesus, which again they always say, well, they don't believe in a God. They believe in other naturalistic ways that this could happen. But the problem is they don't have a defined solution. They just say, well, there must be some other way that this happened. We just haven't discovered it yet. Yeah, evolution doesn't account for all of this, but something else does, and it's going to be a naturalistic explanation. We just haven't figured it out yet. That's most of the time what they say. But I feel that it's a God of the gaps argument in a way, which they oftentimes push on us, where they're like, "Oh, you just keep saying God did it," but they're saying naturalism did it. They just don't know how. Most of the time, that's what I get. Um, so I think that's a big one. They'll just say, "Well, we'll figure it out eventually." Yeah, right now we don't have the answer, but at some point we will. Yeah, yeah. Right. Yeah. Well, so there are some. I take some issues with like radiometric dating. Um, there is a big principle in when you're dating based on radioactive decay. One is that you know how much right, radioactive decay time or measurements are based on the decay rate of like carbon atoms. And in order to assess time length, you have to know one, how many carbon atoms were in that original sample. You have to know the decay rate, and then you need to know um, You have to know with confidence that nothing like affected that sample. There was no change to that sample. Nothing put more carbon in there or took more carbon out of it. It was a closed system. And I feel like that is a very bold claim for a lot of things in the Earth's distant past, where you're saying that this one sediment rock of that there's nothing that changed the concentration of carbon atoms in there. There's big assumptions you have to make. Say this is a closed system, nothing changed, it, nothing touched it, nothing affected it, and therefore we can confidently say that the only change to this makeup was radioactive decay. So that's one thing I take issue with. Um, the other thing you talk about with fossils, um, fossilization is something that I think has, and a lot of scientists agree on this, is that it has to happen kind of fast. You get fossils of uh, fish giving birth or eating. Like I said earlier, you have a fossil of cells in the middle of dividing. So that's not something that can happen slowly. Fossilization is a very quick, sudden thing that has to happen. When you start talking, open up the idea of maybe there's a catastrophic event that happened in Earth's history that could have suddenly uh, kind of made all these changes. And if you look at kind of the layers, this is also something that I think that's funded by the Answers in Genesis Institute. If you look at the layers of rock, it would line up with the idea of a sudden flood happened, kind of upturned the whole Earth, get this sudden fossilization of a lot of life. Um, and it starts out at the bottom, like marine life at the very bottom, where the Earth broke apart and waters erupted out of, and that kind of goes up more and more the chain to land animals. There's another big thing is one thing the scientists are confused about is that you see these marine life in fossil deposits that are in the middle of continents that are way above sea level. And one of the evolutionary theories that they tried to actually dispute the Cambrian explosion was, well, maybe originally the waters rose slowly over time and covered all of the Earth, and then they receded, and that's how you get animal life on the middle of continents. But again, fossilization has to happen quick. So you could have water rise and go above all the continents, but then you need a sudden change to happen to leave those fossils there. Otherwise, they'd be dragged back down into the bottom of like um, oceans, and then you never get to see them. I think that the story of the fossil record actually lines up fairly well with the idea of a sudden catastrophic event in the Earth's past that produced all these fossils, and and then there this catastrophic catastrophic flood could be a reason why you see these fossils of marine life in the middle of continents where there would otherwise not be. You do what? Um, I guess I haven't really thought. I mean, I'd be fine with that. I haven't thought too much about that. Yeah, no young Earth. Yeah, yeah, yeah. I I would have. I mean, I would be more willing to say, okay, the Earth, the universe as a whole, it could be very old because it talks about God created the heavens and the earth in the beginning, and then kind of like hovered over the waters for whatever time, and then he started making life. So I would be perfectly fine with saying, yeah, the Earth could be like itself pretty old, maybe even, and the universe could be very old. But I would still hold that life itself is and not something that I would say happened over evolution, using death as a mechanism for it. That's my personal take. Again, you're very right though. A lot of Christians have multiple different views on that, and sometimes we can have a lot of infighting on that, which I don't want to like and I don't want to do. The big point is to show naturalistically, without intelligence behind it, life doesn't make sense. Right? Sure. Yeah. Right. Yeah. Right. Yeah. Absolutely. Yeah. Other questions? This instructive. Do you think I was gonna do another one on like chemical evolution for like the first life? That's just like yeah. That's what I spend most of my life reading about. As long as I can remember, I've always been like interested in it. I think from an early age, I was brought up in a very Christian home, and the gospel was presented to me as truth, as fact, and then you start to grow up, and I mean, obviously, still believe that, but uh, I guess from an early age, I was always kind of like a skeptic for whatever reason, um, and I would be afraid of the biggest thing for me was believing a lie. And it kind of got to the point of, am I believing this just because my parents are telling me it's true? Am I believing it because all my friends at church are saying it's true, or do I actually believe it's true? So that's why I kind of had like this crisis and wanted to read more about it to figure out if it's real or not. And also, if I'm going to interact with, I have a lot of like I would say non-church going friends or non-Christian friends. If I'm going to interact with them, they're going to obviously ask me questions about this. I need to know how to respond. So I can only say from a very early age, I was very interested in it. Yeah, yeah, definitely in high school. Before that, I was always been interested in it. So this has just been my life. So yeah, yes, good question. It's gotten. I mean, because you can have this mindset of what else? What if there's something else out there that's going to disprove this? What if there's something? It's the same thing that like the naturalists would say. Well, we just don't know yet. There's something down the road. And that could kind of like haunt you for a little bit. And for me, at a certain age, it did. I was like, well, what if? Yeah, I understand this stuff is there's this evidence, but what if there's something else on the road that like, I just don't know yet, and it's going to disprove it? But it got to the point where it's like God is saying, listen, I've proven myself to you time and time again. Like I've shown you this evidence, the evidence of biology, the evidence of the heavens. Whenever I had a question, whenever I had a doubt, and I would seek out the answer, it would be confirmed that God is faithful in that sense. That like the evidence still points to Him. So it got to the point where I'm like, well, who knows what we discover in the future? But at this point, every time um, I've questioned it, the answer's always been to confirm that God is still God and God is the creator. So at that point, I just had to trust Him, right? And that's what faith is. Like He gives you evidence, but then He's like, you don't know what tomorrow's going to bring, but I've shown you I'm faithful. Now trust me. So that's kind of where I got to. That's the point I had to get to. Say, yeah, you've shown yourself to be the God out of all of this. So whatever I get shown in the future, whatever new theories, whatever else comes up, I'm gonna believe that you have an answer to that. That's a good question. Any other question? No? All right. Guess I'll pray and then we can go. All right. Father God, thank you for allowing us all to come together learn about you, your creation, learn about your majesty, your glory, your wisdom. You designed the world with a purpose and in wisdom. Thank you, Father, for your love, for your faithfulness to us, your grace and mercy. Most of all, Father, thank you for giving us your Son, Jesus Christ, as a sacrifice for our sins, as an atonement to reconcile us back to you. Thank you for your gift of salvation. Lord. It's in Jesus Christ's name.